Hello students, we are going to study how are electrons distributed in different orbits or shells. Okay, actually we have studied about the models, isn't it, till Bohr model of structure of atom. Okay, after that the neutrons was also discovered. Okay, and then this Bohr and Bury. Okay, they said how these electrons are arranged in the orbits. Okay, Bohr said that yes, in their orbits are energy levels where electrons are there. Okay, and they are having that energy of that shell, and as the result they are revolving around the nucleus, and as the orbits are having specific energy, they are not radiating energy, and as the result they will move along the shells only with that energy, isn't it? So now we are going to study how the electrons are arranged in different orbits K, L, M, N, okay, which we have studied. Okay, so this was said by this arrangement of electrons in the shells or the orbits was said by or was formulated by Bohr and Bury. Okay, in this they said what? Maximum number of electrons in a shell. Maximum number of electrons in a shell must be how much? It is 2n square. Where what does this n represent? This n represent what? The orbit number. Okay. So here this n represents what? The orbit number, or you can say energy level, or also you can say what? Shell number. Okay, so when I am talking about the first orbit or the K shell as said by Bohr, okay, so first if I am saying number of orbit is 1, so 2n square, 2 into 1 square, it becomes how much? 2, isn't it? Second orbit is known as what? L shell, isn't it? So here 2 into what? 2 square, isn't it? You can see these are what? The n square, okay, the number, orbit number. Okay, so what will it become? 2 square becomes 4, 4 into 2 becomes how much? 8, isn't it? Likewise, when we go to the third orbit, that is the M shell, okay, here 2 into what? It becomes 3 square, isn't it? 3 square is equal to what? 9, 9 into 2 how much? 18. So, we have studied right now how the electrons will be filled in this K element according to the formula 2n square. Who said this? Bohr and Bury. He formulated it, isn't it? And you have seen that yes, in K it will be 2, in L it will be 8, and in M it will be 18 right now, which I have explained you. But one thing you should remember, that maximum number of electrons accommodated in the outermost shell is 8 only. And so when in 9th level, when we will be arranging the electrons in the different orbits, we will be going by the method 2, 8, 8 and so on. Okay, getting? Again it will be 8, okay, it depends how much electrons are there, okay, in that manner we will be arranging. For example, I will be saying to you here what, like if I am saying sodium, it is consisting of 11 electrons, isn't it? And if I am saying about potassium, okay, it is 19. Now how you will be writing? It will be 2, 8 and 1. Like that, in potassium we will be writing 2, 8, 8, 1. You can see over here how we are doing. You will be not writing 2, 8 and then 18 and then in that manner. Okay, you will be arranging in this manner when you will be writing the electronic configuration of the elements. Okay, now electrons are not accommodated in a given cell unless inner shells are filled in stepwise. Okay, filling. This means what? It is not that we have filled this K, okay, and then we will be filling L and then M, then N, isn't it? It is not that we have filled this K shell and then we are filling this M shell. Okay, we have to fill L and then M and then N. So when I am talking about here K, L, M, N, okay, in this what will be the inner shells? M, L and K, isn't it? And N is the outermost one. So first these will be filled only, then this will be filled. So first K will be filled, then L will be filled, then M and then N. Okay, it is not that we can fill K and then M and then L. No. Getting? So electrons are not accommodated in a given shell, okay, unless inner shells are filled. Okay, it should be filled stepwise manner. Okay, now let us study about electronic configuration, how the electrons are arranged in the different shells of the orbits. Okay, I said to you, follow what? 288. Okay, go on arranging in this manner. Okay, so let us take some elements. Starting element, take like sodium. Okay, number of electrons is how much? 11. Okay, now how it will be arranged? 2, 8 and 1. Okay, take magnesium. It will be, its atomic number is 12. So it will be 2, 8 and 2. Okay, any element you take, lithium you take. Okay, lithium. How many electronic, this number of electrons? 3. Isn't it? Atomic number is 3. So now here it will become what? 2 and 1. Come on, let us arrange in different orbits. Suppose if I have taken off lithium. Okay, this is what? Lithium. This is the nucleus. Okay, first shell, second shell. It is ending up in 2 shells only, orbits. The first it is consisting of 2 and the second 1. Come to sodium. Okay, Na. 1, 2, 3. You have seen, you have done it also. So it becomes what? 2, 8 and 1. Okay, likewise you can do of magnesium also. Instead of 1, how many will come? 2, isn't it? So this is how you will be arranging in the different orbits the electrons. Okay, so basically you have, I said to you in earlier classes also, you have to learn what? The elements with the atomic number, how much? 20. Okay, so which element has got atomic number 1, which has got 2, which has got like 1 is hydrogen, isn't it? In that manner you have to learn it till 20, and 20 is of calcium. Okay, and so that you can do whichever configuration it is being asked. Okay, whether it is other bond formation, anything you can do if you have learned in class 9 at least the elements with atomic number 1 to elements atomic number 20. Okay, and it is given in NCERT. Getting? I think so 19 and 20 is not given, only till 18 it is given. 19 is potassium and 20 is calcium. Okay. So now let us study what valency. So what is this valency actually? Okay, valency is the combining capacity of an element. I said in one word, isn't it? Combining capacity of element. What did you understand now? Actually it is the capacity of the element to gain or to lose the electrons. By gaining and losing the electrons also here we can take out the valency. Okay, and it defines the valency only. Like for example, electronic configuration we have understood now. First let us do the electronic configuration of some elements I have written over here. Okay, like magnesium, its atomic number is 12. So electronic configuration becomes what? 2, 8 and 2. So this 2 is a small number, isn't it? Naturally this magnesium can give out this 2 electrons, or it can give this electron to another element and form a bond between it. Okay, and then when it is forming a bond, naturally what it is doing? It is combining with that element, isn't it? So its valency becomes what? 2. Now if we say about sodium, its atomic number is 11. Okay, its electronic configuration becomes what? 2, 8 and 1. So valency is what? Small number 1, isn't it? Now fluorine, it is 17. Okay, no sorry, fluorine atomic number is 9. Okay, so what happens here? It will become what? 2 and 7. Now see, when it becomes 7, then you will not write its valency is 7. It will be how much? 8 minus 7. Okay, because to become stable, how much electrons are required? 8 electrons are required, isn't it? So maximum which can be filled in the outermost orbit is 8, isn't it? But here it is coming 7. So we will not write the valency 7, we will be writing what? 8 minus 7, and that becomes what? Here you will be doing what? 8 minus 7, and now the valency becomes 1. Okay? Getting? Now, like chlorine, when we are saying about chlorine atomic number is 17. Okay? It becomes 2, 8 and 7. Here also what you will do? 8 minus 7. Okay? That is 1. Okay? Now, in this, now, you have seen here the valency, how we are taking out. Now, here one thing you remember. Okay, when the outermost shell is consisting of 2, 1, 3 or 4 electrons, okay, then they will have that valency only which the electrons are present in the outermost shell. Outermost shell is known as what? Valence shell, and the electrons present in the outermost shell is known as valence electrons. So now the number of valence electrons when it is 2, 1, 3 or 4, 1, 2, 3 and 4 in the outermost shell, what happens? The valency is that only. But as soon as if the valence electrons are 5 in the valence shell, okay, what happens? You will be minusing 5 from 8. So 8 minus 5, it becomes what? 3. Getting? So in this manner you will take out the valency. Now I will like to show you how these elements combine. Okay, like first one, it is written what? Magnesium. Okay, so magnesium we are seeing what? It is 2. The valence electrons is how much? It is 2, isn't it? So now take oxygen. Okay, what is the atomic number of oxygen? It is 8, isn't it? So what will be 8? There will be 2 and 6, isn't it? I said to you, if it is coming 6, will the valency be 6? No, it will be 8 minus 6. Okay, and that becomes what? 2. So its valency is also 2. Now see what will happen. How will you arrange it? Like if we are talking about magnesium, okay, it is coming 2, 8, 2, isn't it? So just start arranging the electrons. In the first it is how many? 2, isn't it? Second it is 8, isn't it? Now next in the last you will see how many are there? 2, isn't it? So 2 electrons in the last. Now let us do, this is of what? Magnesium, okay? This is the nucleus. Now let us do for oxygen, okay? Here oxygen, okay? So first shell, second shell, okay? This is for what? This is for oxygen, okay? So first it is coming how many? 2 and then 6, isn't it? 1, 2, 3, 4, 5, 6. Now what will happen? It needs 8 electrons and here also 8 electrons. Now what? How many electrons now will be participating? You will be seeing these 2 electrons, and when here what is happening? Transfer of electrons is taking place, isn't it? Both the electrons has been transferred over here. So here you can see I said to you it is the combining capacity. Here how many electrons are participating? 2 electrons are participating, and this is taking the 2 electrons. Okay, so valency of magnesium becomes 2 and oxygen is also 2. Naturally what happens? Here magnesium is giving electrons to what? Oxygen. Transfer of electrons is taking place. So we are saying this as a ionic bond. Getting? So in this manner what happens? The combination takes place. Other bonds are also present, covalent bond and other, but it is not in your syllabus right now. Okay, so this is all for today. Hope you might have understood it. Good day. Take care.